Hello everyone, today I am going to talking about a AC adapter. AC adapter is a device which is used to convert AC into a direct current, that is alternating current into direct current. Here the input voltage of AC is 220 volt and the output voltage of the adapter is of 10 volt. In today's video, I am going to show you the different components which is used to manufacture a AC adapter and how there is a conversion of AC alternating current into a direct current. This is the internal view of the AC adapter. This is the transformer, these are the diode, and this is the capacitor. One by one I am going to explain about each of the element in detail. So let's start talk about transformer. Transformer is a static device which is used to a transform of voltage from one circuit to another circuit without any internal connection with the help of mutual inductance. Transformer contain two windings. First one is primary winding and second one is a secondary winding. Primary winding is connected to the input of the supply and the secondary winding is connected to the output of the supply. There are two types of constructions of the transformer. First one is core type. In the core type transformer, the primary and the secondary coil are mounted on the different arms of the core. But in the shell type transformer, primary and the secondary winding is on the same arm. Cell type transformer is in the AC adapter. As you see that the winding primary and the secondary winding is mounted on the same arm. These windings are not internally connected to each other as it is separated by a plastic which is an insulator. Now according to the working, it is divided into two types. First one is a step-up transformer. Step-up transformer is defined as when the input voltage is lower than the output voltage, then it is called a step-up transformer. In the step-up transformer, the number of turns at the primary side, primary coil, will be less than the number of the turns of the secondary coil. And the second transformer is a step-down transformer. In the step-down transformer, the number of turns of the primary coil will be higher than the number of the turns of the secondary coil. As you see in the figure, this is the step-down transformer figure in which the primary coil have the number of turns 1, 2, 3 and 4 and the secondary coil have the number of turns 1, 2. So it is a step-down transformer. Second element is a diode. This is the diode IN4007. This diode is basically used for the rectification purpose. So what is diode? Diode is a two-terminal device. As you see that the diode have a two-terminal. It is an electronic component which is used to rectify or convert AC signal into a DC signal. This is the symbol of the diode. The diode have a two terminal. This is the positive terminal of the diode, which is anode, and this is the negative terminal of the diode, which is cathode. And this is the real view of the diode as anode, and this will be the cathode. There are two configurations of the diode. First one is forward bias. In forward bias configuration, the cathode terminal of the diode is connected to the negative terminal of the battery, and the anode terminal of the diode will be connected to the positive terminal of the battery. So this is the forward bias connection. In the forward bias connection, the diode will allow current to pass through it, and the diode will be in working state. Now the second is reverse bias. In the reverse bias connection, the cathode terminal of the diode will be connected to the positive terminal of the battery, and the anode terminal of the diode will be connected to the negative terminal of the battery, and this is called reverse bias configuration. In the reverse bias configuration, the diode will not allow current to pass through it, and it is called reverse bias configuration. Third element is a capacitor. This is a smoothing capacitor. So what is a smoothing capacitor? A smoothing capacitor is defined as the capacitor that acts as to smooth or even or the fluctuating signal. As this transformer step down the voltage and these diodes are rectify the AC signal into DC signal, there is a fluctuation in the DC signal. So this smoothing capacitor will be help to smooth the fluctuating DC voltage that comes out from these diodes. Capacitor is divided into two parts. First one is ceramic capacitor. Ceramic capacitor doesn't have any sign convention, so you can connect a ceramic capacitor in any direction. But the second type of the capacitor is electrolyte capacitor. Electrolyte capacitor has a sign convention, so the positive terminal of the electrolyte capacitor should be connected to the positive terminal of the battery, and the negative terminal of the electrolyte capacitor should be connected in the negative terminal of the battery. This is the circuit diagram by the help of which you can easily make your own AC adapter. This is the transformer. The primary coil of the transformer is connected to the input of 220 volt 50 Hz AC voltage, and the secondary coil of the transformer is connected to the point A and B. This is the bridge rectifier. There are the four diodes used in the bridge rectifier: D1, D3, D2 and D4, and this is the smoothing capacitor connected at the end of the output of the circuit. Now I am going to describe the working of each component with the help of this circuit diagram. So in the positive half cycle of the AC voltage during 0 to pi, this side will be a positive and this side will be negative. As this side will be positive and negative, it will be positive and here it will be negative. Now as this terminal will be positive and this the diode D4, this terminal will be a cathode, that is negative, and this terminal will be a anode, will be positive. So diode D1 is a forward bias and diode D4 is a reverse bias configuration. By this, the diode D1 will be allow the current to pass through it. As it comes here, the diode D3 will be a reverse bias. So the diode D3 will not allow to pass current through it. So the current flow through the load and comes to the negative circuit, and as this flow, the current flows through this and it comes here. Now when it comes here, the diode D4 will be a reverse bias and the diode D2 will be a forward bias. So it will flow through this, and by this the circuit will completed, and we get a DC output voltage at the output side. During the negative half cycle from pi to 2 pi, the upper point of the secondary coil of the transformer will be negative, and lower side of the transformer of the secondary coil will be positive. As this will be positive, here it is positive and here it will be negative. When this will happen, the diode D4 will be forward bias and diode D will be reverse bias. In this condition, diode D4 and D3 will be forward bias and diode D1 and D2 will be reverse bias. By this we can easily transform the AC signal into DC signal with the help of the bridge rectifier. And as you see inside view of the AC adapter, this is the primary terminal and this is the secondary terminal. From the secondary terminal, the wire is connected to the bridge rectifier, which is made of 4 diodes, and there is a smoothing capacitor at the load side, and here the output will become, and here we get a constant DC voltage. Similarly happens in the circuit diagram. As you see the circuit diagram, similarly things will happen. So this is all about the AC adapter. This is the symbol of the voltage regulator. Voltage regulator will help to provide a constant DC voltage at the output of the circuit. But as you see in the AC adapter, there is no any voltage regulator, so it will not provide any constant DC voltage. Let me show with the help of multimeter. As I connected my AC adapter to a supply and I switch on the supply, I get a 12.7 DC volt at in the multimeter display. But the manufacturer has mentioned that it will provide 10 volt DC voltage, but it is providing 12.7 volt DC voltage. So we are not getting a constant voltage that the supplier has mentioned. So with the help of the voltage regulator, we can able to provide a constant DC voltage at the output of the circuit. Voltage regulator is defined as an electromechanical component which is used to provide a constant voltage at the output of the circuit. It contains 3 terminals: input, output and a ground. Input is connected to the input side of the circuit, output is connected to the load side of the circuit, and the third pin of the voltage regulator is connected to the ground. There are 2 family of the voltage regulator. First one is 78XX. It is for positive voltage, and if there is a mention that 7805, it means it will provide positive 5 volt constant voltage. And another family is 79XX. It means if 7905 will mention in the negative 5 volt constant DC voltage at the output end. So thank you for watching my videos. If you like my videos, then like it, share it and comment down below. Thank you so much.